My name is Mohamed Abdelrahman Khattab. I'm a graduate student in Harvard Extension School for the Data Science Master degree. Today, I'll be presenting my final project for the Natural Language Processing course, which is CSCIE 89B. NLP in specific is very important to me because over my last 20 years experience in computer science, it was a little bit away from AI. 1 year ago, I decided to shift my focus into AI and I decided to start from the data science layer. And recently I joined a native AI company called Uni4, which is very specialized in conversational AI. And hence, I chose the case study of my project to be intent detection, which is a core component of conversational AI systems, such as chatbots or virtual assistants. The goal of this use case is to classify short user utterances, like I lost my debit card, into predefined intent categories. This is a quick introduction of the use case. The use case mainly is to demonstrate intent classification on Clinic 150 dataset using two NLP approaches, classical baseline and advanced model. For the classical baseline, I choose TF-IDF plus logistic regression. And for the advanced model, I choose custom curious transformer. My motivation, like I said, and like I also mentioned in my proposal, is to get more information about this area, more practical information about this area, because it's a core component of my career. The key outcome of the use case would be to compare accuracies, visualize results, and discuss pros and cons of these two models for this topic, which is intent detection. The environment that I have is MacBook M3 Pro. I installed TensorFlow 2.17. For the usage of LLM, I used Grok for environment setup, troubleshooting, and building the code for the two models. I'll take you now through the case itself. Now a little bit more focus on the problem itself. So the problem is to classify short user utterances into one of 150 predefined intents using supervised learning. And then we compare classical baseline, like we said before, TF-IDF plus logistic regression, with advanced neural model, which we choose curious transformer. The focus is to analyze the behavior on short lexical utterances, evaluate if transformer captures context better and outperforms baseline in accuracy. I will take you now through the details of each model, the pre-processing, and then at the end we will do the comparison. Let me quickly explain to you the dataset that we used. It's Clinic 150. It's very well-known public dataset for intent detection. It is known as OOS eval dataset as well. This dataset contains approximately 22,500 labeled utterances across 150 intent categories. The utterances are intentionally short, 3 to 10 words, which makes the dataset well suited for studying intent detection. Now, this dataset is split into 15,000 training examples, 3,000 validation examples, 4,500 test examples. The data is provided in JSON format, where each example is pair consisting of text and its corresponding intent. Now, I included the URL of this dataset in the report, in the slides, and in the code. Unfortunately, I couldn't load it directly into the code because of the SSL restrictions, because I'm using like my company laptop. However, I downloaded it. I had to download it manually, but I'm uploading it with my submission. I also mentioned the URL specifically, and I mentioned also a snippet of the data structure for your reference. Now let's get into the pre-processing. For the preprocessing, we use minimal and transparent preprocessing. I used lower casing, trimming white spaces. I didn't use any stop word removal, no stemming or lemmatization. Same preprocessing applied for both models. The rationale behind that, to preserve semantic information, to avoid bias between models, and to reflect realistic short text pipelines. Let's focus on the first model, the baseline. I use TF-IDF, as I said before. It converts, of course, text into numerical feature vectors based on word frequency and inverse document frequency. In this project, the maximum number of features is set to 10,000. Both unigrams and bigrams are used. Stop word removal is disabled, as I mentioned before, for the reasons that I mentioned before. The TF-IDF features are then passed to a logistic regression classifier, configured for multi-class classification across 150 intent categories with maximum of 1,000 iterations. This model is fast, stable, and widely used for short text classification tasks. And for that, we got very good accuracy of around 0.89, which is very good for a baseline. Let's now compare it to the advanced model with the transformer. For the transformer-based neural network implemented from scratch using Keras and TensorFlow, text inputs are tokenized and padded to a fixed length of 30 tokens, then mapped to 128 dimensional embeddings. The core of the model is a custom transformer block that includes the following: multi-head self-attention with 4 heads, a feed-forward network, residual connection, and layer normalization. The transformer output is pooled using global average pooling and passed through dense layers, ending with a softmax output layer over the 150 intent categories. The model is trained using the following: Adam optimizer, learning rate of 0.001, categorical cross entropy loss, batch size of 64, 15 training epochs. This transformer achieves test accuracy of 0.8, almost 87, which is less than what we received from the baseline, the TF-IDF plus regression model. Let's discuss this in more details. When we compare the two models, the behavior of them based on the accuracy, we clearly see that the baseline model, TF-IDF plus logistic regression, outperformed that transformer model. So the baseline, we got almost 0.89, while for the transformer we got almost 0.87. Looking at the training behavior of the transformer, it provides very important insights. The training accuracy increased rapidly and approaches almost 0.99, while the validation accuracy stabilized around 0.86 or 0.87. After a few epochs, the test accuracy closely matched the validation accuracy. This pattern indicates overfitting. The model fits the training data very well, but does not generalize proportionally to the unseen data. The close alignment between validation and test accuracy suggests that the evaluation is reliable and the performance gap reflects genuine generalization limits, not a data leakage. Now, there are a lot of lessons learned from this. It is kind of surprising to me, at least, and that's the whole thing about it, to learn and to get practical experience. Now, let me take you through what worked, what didn't work, and focus a little bit more on the lessons. Now, based on the comparison and based on the experience that I gained through this project, let me take you through a few areas. First, what worked? Actually, the classical TF-IDF baseline performed strongly, and this was something that worked very well. It was well suited to the short keyword-driven nature of the dataset, claimed 150. The code ran reliably and the preprocessing choices avoided common issues with short utterances. However, some aspects didn't work well as well. The transformer model overfit the training data and did not outperform the baseline. That is likely due to the following: very short utterances, high model capacity, lack of pre-training embeddings. Without pre-training or fine-tuning, the transformer struggled to generalize better than the classical approach. This highlights an important lesson, to me at least. Neural models not necessarily outperforming the baselines in all cases, especially on small or lexically driven datasets. The conclusion of this project demonstrates that the intent detection on short utterances, classical NLP methods can remain highly competitive. While transformer models are powerful, their effectiveness depends heavily on data size, task complexity, and pre-training. Strong baselines are essential for honest evaluation. This project emphasizes the reproducibility, transparency, and practical understanding of NLP techniques rather than model complexity alone. And that's why I'm very happy with the result, and I hope you accept it also as a successful project. Thank you very much for staying until now. This was the conclusion of my project. I included also the report. I included the slides, the code, and PDF extract of the code. Thank you very much. Bye-bye.